This mark is fine, right?
Yeah.
All right. What do you understand by it, Romeo? If you don't understand that, even I accept that.
Isn't that the second derivative?
Sorry?
Is it the second derivative?
Forget about the derivative.
Oh. Okay.
But yeah, normally there.
Yeah.
But then what does this actually mean in layman terms? Right, any thoughts? No? Chris? This was covered in grade 11, right? This was no hang from that. It's been too long now, right? Okay. Let's take an example. Let's say, I can give you multiple examples. Let's take the example of let's say you are driving a car, right? And this is your distance versus time graph of how you're driving. Let's say you're driving at a constant speed, and then you reach your destination, and eventually you stopped here, right? So this time is, let's say, 10 hours, and the distance covered is, let's say, 1,000 kilometers, right? If I ask you, how much was your average speed here?
Distance over time.
So you'll say, okay, from started here, ended here. So this point is 10, 1,000, and this point is 0, 0. Right? So he said, okay, I started at my house at 6 a.m. and it took me 10 hours to reach at my destination, which is 1,000 kilometers. So I spent 10 hours, I covered 1,000 kilometers, so that means 1,000 divided by 10, I must be driving at 100 kilometers an hour on an average. Correct? Easy? Now if I use the concept of slope here, I've got 2 points, x1, y1 and x2, y2. Aishka, yes? What is slope? Rise over run. Here the rise is the distance, so that means change in the distance, which is y2 minus y1 over x2 minus x1. What is y2 minus y1? Change in y. And what is x2 minus x1? Change in x. So if you plug that in, you get the same answer. 1,000 minus 0 over 10 minus 0, 1,000 over 10, which is 100 kilometers an hour. So your slope is 100. Yes? Slope in the distance time graph is nothing but speed, because the top one is distance, bottom one is time. So we're talking about change in the distance over change in time. So your slope is actually measuring the speed for distance and time graph. Yes? So that was on an average. So how do you find the average slope or average rate of change? So this is called the average rate of change of y with respect to x. Average. How do you find? So for average rate of change, you need 2 points. So average rate of change will be 2 points. What is 1,000 here? If let's say my this was f of x is the distance, and let's say the distance was x. Suppose that was the function, right? Or maybe let's say x over 10. Let's say this was my function of the line. That was my line, the function itself, for which I've plotted this graph. Let's say. So for 0, f of 0, which is the x1, I have 0. For f of 10, I have 100. So that is the y value, y1, and that is y2. So average rate of change is actually, if you've got 2 points, so it is f of b minus f of a over b minus a. So if you've got 2 points across which you are measuring the average rate of change, so this is how it's going to be. So what it actually means is that you've got a line like this, and you've got 2 points here. This point is a, and this point is b, and this is your f of x, and this is your x. So this point is what? A comma f of a, and this point is b comma f of b. Does that make sense? So y2 minus y1, f of b minus f of a, over x2 minus x1, b minus a. So that's called the average rate of change. So whenever in the question you'll be asked for average rate of change, you will be given 2 points and the function itself. So far with me? Let's now, I'm just taking this off now. Let us now try to talk about the instantaneous rate of change. Can you tell me how much will be the speed at this point? How much will be the speed at this point? What will be the speed? How will you find that? You can find the distance, which is this value, but how much will be the speed? How will you find that?
Rise and run.
How do you find the rise? Let's say I tell you that this is 5. So obviously this is x over 5, 5 over 10, which is whatever, half. Let's say this is half. Let's say this is half. So this is 5 comma half, hypothetically. Tell me, how will you find the speed here, the slope here? Speed is the slope in this case. What is rise over? How will you find rise over run? Go for it, that's fine. It's okay to go wrong. If you don't know, that's fine.
Would you use first principles?
Exactly. You will not use any of these points. I am asking you to just use this point and give me the slope. But the problem of finding the slope is y2 minus y1 over x2 minus x1. Slope needs 2 points. Here I'm just talking about on the 5th hour, what is your speed? You can't just find it. You said, give me the second point, I'll let you know. The moment I give you the second point, you're not finding the speed at this point, you're finding the average speed between 2 points. This is called the instantaneous rate of change. Change at a given point in time. That's it. It doesn't need a second point. How do you find the instantaneous rate of change? Think about it when you're driving a car. If you're sitting with me, or I'm driving the car, and you ask me what is the speed, I look at the speedometer and tell you that's the speed. Right? That is called instantaneous rate of change. Now let's try to understand how do we find the instantaneous rate of change. I'll take this off the board and I'll try to explain you how do you find the instantaneous rate of change. I think I did talk about, and it all connects to derivatives at the end of the day. Am I making sense? I hope I'm not making you feel sleepy, right? All right, let's say you have these 2 points here. X is, let's say, 5 and this is 10. And I ask you find the instantaneous rate of change between the two. So what you'll say, okay, that's the point. That's the point. So this is 10, 100 and this is 5, 10. You can give me this, right? Not a problem. Now let's try to push this 5 here. Now this 5 sits here. And I ask you, okay, give me the rate of change between these 2 points. You'll say, easy, right? Now I've shifted here. And whatever this is, right? Let's say this is 80. So let's say this 5 is now 7 basically. This is 7, 80. You can still find the rate of change. This is also average. Let's try to push it even closer to 10. I say 9. So this point comes here. So let's say 9, 90. Let's say this is 90. You can still find the change, right? Now I push it even closer. Let's say it's here. And this point is 9.90. So what you'll do is you will push this even closer. And so this is 9.90 comma something. And you can still find the rate of change. Now if I say push it even more closer. So let's say now it is so close that with naked eye you can't differentiate between the 2 points. So let's say this point is, the second point is 9.999999999 until like 100 decimal places. So approximately, don't you think these 2 points are same? Right? These 2 points are same. So I approximate this point to basically 10. So what have I done? What have I done from here to here to here to here and to here? This was the distance between this point and the point 10. So this was, let's say h was the distance. When I came to this point, I reduced that h. When I came even more closer, I reduced the h even further. And when I was so close here, somewhere, h would be what? H would be the distance between the 2 points. H might be 0.000000001. The distance between the 2 points is almost 0. So what is happening to h here? Is it not h approaching 0? Yes or no? Is it not h approaching 0? So this point, now the 2 points are f of x minus h minus f of x over x plus h minus x, limit h approaching 0. This is the slope. This was 10, this was 10, and this was that point which was getting very, very close, right? 9.999999. That's the x coordinate for 10, and that's the x coordinate for this point. Rise over run. But you see here, I applied a limit. And I say h tends to 0. That means the 2 points are literally on top of each other. So we still found average rate of change, but we applied limit on top. And what is this? Is this not the first principle of derivation, of differential? Right? So we conclude that if I were to find the instantaneous rate of change at a given point, I just need to find the derivative at that point, and that will give me the speed in this case, if it is distance versus time. So now, if I were to summarize average versus instantaneous rate of change, it's as simple as, sorry, I took a bit longer to explain that. I could have given this straight away to you. Is that the average rate of change needs 2 points, and it is just finding the slope between the 2 points, the regular slope, which is f of b minus f of a over b minus a. This is nothing but y2 minus y1 over x2 minus x1. Whereas the instantaneous rate of change is all this stuff here over b minus a, but limit, the distance is 0 between the 2 points. Or shall I say, if I were to rewrite in the form of first principles, if I say f of x minus h minus f of x over x plus h minus x, where limit h tends to 0, or this is nothing but dy by dx. So if I've got a function f of x equals to x squared, and I'm asked, can you find the instantaneous rate of change for this graph at x equals to 5? It's very simple. You find f dash x. It is 2x, plug 5 in the derivative, and you get 10. That's the instantaneous rate of change.
Do we have to use the formula, or can you just do dy dx?
dy by dx. Plug it in. Sorry, I built up the story because I wanted that you shouldn't be just mugging it up, but it should have something in your mind that what exactly that is. Does that make sense?
Also, for the formula of the first principle, do we have to do x plus h minus x, or can we just do h?
H.
Okay.
I actually wanted to keep them separate so that you know that's y2 minus y1 over x2 minus x1. All good?
Yeah.
Make sense?
Yeah.
All right. Now, let's do a question. Let's say your f of x is x squared plus 2x. Can you find the average rate of change? Average rate of change, and I say ROC, where x belongs to 2, 3. And can you find the instantaneous rate of change? At x equals to 2. You see the difference between the two questions. Your average rate of change will always give you 2 points, 2 x values, whereas the instantaneous rate of change will always give you 1 value. Go for it now. Everything's given to you clearly on the board.
I'm trying to figure out what I made a mistake on.
Sorry?
I'm checking the mistake for the average rate of change.
Alright, let's quickly check. Now, average rate of change needs f of b minus f of a. If this is a and this is b. Ryan, did you do f of b first and plugged 3 here? So your f of 3 is 3 square is 9 plus 2 times 3 is 6, which is 15. And then what is f of 2? 4 plus 2 times 2 is 4, which is 8. And then you apply this formula, which is f of b, which is 15 minus 8 over b minus a, which is 3 minus 2. So what is that? 15 minus 8 is? Answer is 7. Where did you go wrong, Ryan, here? What have you not done? Tell me, that's okay. Let's discuss each other's mistakes here, right? Because we got 4 people doing mistakes. So if one does mistake, 3 learn. Right? So 4 doing mistake, that means everyone's learning 4 mistakes. 16 mistakes that we're learning together, right? That we can avoid. Tell me. What did you do here, Ryan?
I'm trying to figure it out.
Sorry?
I'm trying to figure out my mistake.
And who else did not get 7?
It was just my simple addition and subtraction.
Come on. I tell you one thing. If you show this in your exam, unless it is a 1-mark question, they are only concerned with the answer. If it's a 2-mark question, you still get some marks if you're showing all of that. If your last addition and subtraction is screwed up, you lose half a mark there. Right? So always anything beyond 1-mark question, please show the steps. Right? Every step counts. Right? And where did you go wrong?
I wrote the wrong equation. I wrote x squared plus 3.
Come on. Okay, what about here? Instantaneous rate of change. Chris was right. So who else got a 6 here? You got a 6? You got a 6?
Which one? No, I haven't done it.
This one.
No.
Right?
No, I got a 5.
Okay, tell me, how did you do it? What was the first step you do? Ryan's gonna answer and then
I
Romel's
did it
will.
wrong.
Sorry?
I did it wrong.
What?
Like the equation, the whole thing.
So what will you do in the first step here? Tell me that. Give me your thoughts, that's okay, right? We're brainstorming together, it's okay. If you don't know, you don't know, that's okay.
Yeah, I know how to.
Instantaneous rate of change, so you need to find the derivative. So you find the derivative of this function. And how do you find the derivative of this function? This is 2x plus 2. That's the derivative of this function, f dash x. Plug in 2, you get your answer. Does that make sense? Yes? No?
Yep.
Alright. Let's try one more. And probably then I'll give you one. You want me to go to the next topic straight away and then we can do a few questions. I don't think we've got much time. We've got 13 minutes. I want to do stationary points quickly. Let's do stationary points. All right. Shall I take this off the board, please?
Yeah.
What do we understand by stationary points? Chris?
Is the gradient 0?
Good job. Romel?
Yeah.
What gradient is 0, Romel?
The derivative. The derivative.
The derivative is 0. So what gradient are we talking about here? What gradient are we talking about? You're right, derivative, but what gradient are we talking about here? Gradient of whose gradient? Tell me.
Like turning points?
Whose gradient are we talking about? You said gradient equals to 0.
If it's not increasing or decreasing, it's turning point.
Aishka? What gradient are we talking about here?
When it equals 0,
What equals to 0, Aishka?
the gradient
Of
equals 0.
what? Gradient of what?
of the equation, the tangent.
Exactly. Let's say you've got this kind of a graph. Alright? Now, I want to draw, let's find, if I draw the tangent at this point, how will our tangent look like? Something like this. So if I find the slope of this tangent, that means derivative at this point. I need to see a nod, right? I mean, I feel at times you're not getting it, right? So please do a nod, yes? Derivative of the is nothing but the slope of this tangent. And looking at it, just forget about the slope for a second. If this line's like this, the tangent's like this, slope is positive or negative?
Positive.
Right? Positive. Positive. Good. Let's draw tangent in this point. This looks parallel to x-axis. Something like this. What's the slope of the tangent, Anushka? Good job. This slope must be positive. This slope must be 0. Is 0. Now, Ramel, if I draw a tangent here, like this, what's the slope at this of the tangent at this point? Positive, negative, 0.
It's strictly decreasing. Oh, negative.
Decreasing, negative. Yes, Ryan?
Yeah.
Anything like this is positive, anything like this is 0, anything like this is negative. And anything like this is?
Positive.
Come on. Come on.
Undefined.
Undefined. It is parallel to y-axis. Slope of a line which is parallel to x-axis is 0. Slope of the line which is parallel to y-axis is not defined. Okay? I'm touching the basics again. Right? Now, at this point, if I were to draw a tangent, probably not possible, but then this is how the tangent is going to be. It still touches the line at only one point. Right? So that's what? 0 again?
Yeah.
Yes. What about here?
Negative.
Chris? Let's see, touches this one. Negative. What about here, Ryan? Come on. 0. What about here, Ayushka? Now, I conclude. Wherever the slope is 0 are called stationary points. You have popularly heard these humps as turning points. So, how do we find the turning point of a graph? Wherever I find the derivative of that graph, which is essentially the slope of the tangent, and I equate it to 0, and I find the value, and that will give me the values of x, where the derivative is 0. These points, now just see a pattern quickly, Romel. Positive, 0, negative. It changed the sign. Positive, 0, negative. So when you see this kind of a pattern of the gradient for the tangent, you call it as a maximum turning point, or shall I say local maximum. Aishka, make sense? Right? Romel, make sense?
Yeah.
Now, Ryan, see the pattern. 0, so not this 0, negative, 0, negative. So that means negative, 0, negative. This kind of a pattern is also a stationary point, but I call it as point of inflection. Is also a stationary point. What about here, Romel? Negative, 0, positive. And I call this as local min. Local minimum. Right? Make sense? So if I give you a function f of x equals to x squared minus 1, can you tell me how will you find the stationary point? Can someone put a thought around it and tell me?
Find what the derivative equals 0.
Is he right?
Yeah.
I don't think so. Is he right? You tell me.
Is the point given to us?
That's what we have to find.
Don't you just 2x equals 0?
2x equals to 0.
Then you get
So
the
what
x,
are you doing actually?
you get the x value.
My dear boy, what are you doing actually? You're just finding the derivative and equating it to 0. That's what he said, no?
Yeah.
And I said it's incorrect. But you thought so. Right? Let's hold on with that thought. What do you think?
I think so as well.
So 3 people thinking the same. What do you think, right? I still feel it's incorrect. What do you think?
I don't know.
That's fine. Find the derivative. Right? Equate it to 0. You get the answer. So f dash x is 2x. Make it 0. So x is 0. Plug the 0 back in here and you get y is minus 1. So your turning point is 0 comma minus 1. So it must be this kind of parabola. 0 comma minus 1. This is 0.
So you know this, like, what does it mean in terms of volume? Because there's always questions like that. Does that mean like that's like the minimum volume or something?
Whenever now, okay, whenever you have these kind of questions where you're given a function of volume or probably area or growth, decay, whatever, and you're asked to find, give me when this volume will be maximum. That's where you get buffled, right? When it is minimum. Find the derivative of the original function, equate it to 0. Find the value of x, plug that value of x back into the function, get the value of x, that's the point. That's the x value. For example, if your volume was a function of radius and you had something like 4 by 3 pi r cube, and I say, tell me for this particular, what is this? This is a sphere. Tell me for this sphere, when will your for what radius you will have the maximum volume, and there will be domain and stuff given to you. So what you do is you find the derivative, equate it to 0, find the radius. So that's the point where your function will be either a max or a min. Right? That's how you find it. We'll do some application questions probably to clear some mud around it. But then from a concept standpoint, whenever you are, and in your CAS, you've got that option to find max or min. Right? But then if it's not given, then any maximum in question, find the derivative, equate it to 0, and you get the value of whatever is your x here. At that point, that'll be either the max or the min.
How do you know if it's the maximum?
Then you plug those values back into your volume function, whatever volume function, and find the 2 or 3, whatever values of x you got. Then you find that and you start plugging that in. And then you will see which is the minimum volume, which is the maximum volume. So, for example, R is 0 and R is 10. So you plug R.